So we saw how to describe center and spread when our data is symmetric, but what we want to look at in this video is what do we do when our data is skewed? What are the best measures of center and spread there? Because we don't want to use the mean and standard deviation, because as we talked about, when the data is skewed, then the mean gets skewed, and if the mean's skewed, then the standard deviation is skewed. So then everything would be off, and we wouldn't want to use those values. So instead, what we're going to do is use the median to describe center and interquartile range to describe spread. So before we can get to the formula for interquartile range, we need to talk about quartiles. So we're going to have three pieces here. We're going to have the median, which is, it could be Q2, like the second quartile. We very rarely say that, it's just the median. But first quartile we label as Q1, third quartile we label as Q3. Essentially what we want to do to our data is, if we have all of our data, we want to split it up into quarters. So the median is going to cut it in half. So that'll be the cutting point for the median. So we'd have 50% below, 50% above. Then what we'll have is another split down the middle. So Q1, so that we'll have 25% of the data below Q1, and then 25% of the data between Q1 and the median. And then up above here, Q3, so our third quartile, which will split 25% of the data between the median and Q3, 25% of the data above Q3. So we'd have as all of our data, but split up into quarters. Now how we do this is very similar to what we did for the median. So let's see how it would work with those two data sets we previously looked at. So for median, we're looking for that middle value. So like we did before, we just move towards the middle. In the case where there's an odd number of values, it ends up at exactly 12 as that balancing point. So that would be our median. For an even number of values, that's where we landed between 12 and 15, so we had to average them. So our median was 13.5. Now what we want to do here is look at, to find the first quartile, we want to look at the lower 50% of data. Now in this first case where the median was an actual data value, it's like we want to take our data and we don't want to look at those. We also don't want to look at the median. So that's why I draw the picture that way with the median, is that 12 is kind of absorbed in this wall between the lower and upper 50%. So what we're going to do is like this. And then when you do this, you basically want to find the median of this data values. Like you just want to go towards the middle here. So it'd be that same process of moving towards the middle. This is a small data set, so it's kind of hard to see here. But what we would end up with is Q1 would be halfway between 3 and 8. So we would take 3 plus 8, divide by 2. So we're going to have a first quartile of 5.5. So that's how we find Q1, and then to find Q3, same thing, is just for the upper 50% of data. So that would land between 15 and 18, would be Q3, average them, and that should be a 16.5. So that would give us our quartiles. And then what you could see is how the data split up. We have one data value there, one there, one there, one there. We have this even distribution in terms of number of data values in our set. With data set B here, same idea. And just like how I drew the wall here, the wall of that median of the upper and lower 50% is actually part of that. So it splits the two. So to see my lower 50% of data, we just cover up and stop at the median there. So moving towards the middle, we start taking off pieces from each side. And in this case, we'd end up at exactly 8. So 8 is going to be our first quartile. And then we're going to do the same thing, except on this side, where we move towards the middle. So we take out that 20 and 15, and we'd end up at that 18, and that would be our Q3. So same process as finding the median, it's just we have to limit the data that we're looking at to find that first and third quartile. To introduce some terminology here, percentile is the same as, actually the definition's kind of over here. Percentile relates to the percent of the data below. So with the median, we'd kind of be looking at how much of the data is to the left-hand side. So in that direction towards the lower values. So we have this 50% of data is below the median. So that would be the 50th percentile. So 50% of the data is below that number. For the first quartile, in terms of how much data is below the first quartile, 25% of the data is below. So that would be described as the 25th percentile, because 25% of the data is below that number. And then third quartile, we want to know how much data is below the third quartile value. Well, we'd have 75% of our data is below. So that'd be the 75th percentile with 75% of our data there. A way to summarize what we're seeing with our data is a 5-number summary. And it's listing out values for the minimum, first quartile, median, third quartile, and maximum. And you can even summarize it like a long coordinate of having parentheses, then put the number for the minimum, put the number for first quartile, median, third quartile, maximum. So like for data set B up above there, what I could do is summarize our findings with the 5-number summary. The minimum is the smallest data value, so that would be 3. We found the first quartile is 8, median 13.5, third quartile of 18, maximum of 20. So reading this out and knowing that's a 5-number summary, I know it's in order. It would tell me the data values for minimum, first quartile, median, third quartile, maximum. So that's a way to summarize our data. In terms of spread, so there's range and interquartile range. Range takes the maximum value minus the minimum value. So with this data set, what we could do for range takes that maximum of 20 minus the minimum of 3. So this has a range of 17 and basically describes how far on a number line that those data values would spread. Issue with this, and what we're trying to avoid in this section, is if we're dealing with skew data, we're probably going to have outliers, and we don't want those outliers to influence our data. And those outliers are always going to occur out at those minimum and maximum values. So this range, it's not a good measure of spread when we have outliers. It's actually rarely a good measure of spread. So not a good measure of spread because it is influenced by outliers. Now the interquartile range, this is going to be a great measure of spread. And in fact, in general, if we're working with the median, this will be how we measure spread. So what we do is we take our third quartile minus our first quartile. So for our example up here, interquartile range, we would take our third quartile of 18 minus our first quartile of 8, which would be 10. And then we're focusing on closer to the middle of our data, that middle 50%, which is great because that would exclude any outliers that are out in the tails there. All right, so let's look at what if we change that data set B? What if we threw in an obvious outlier that's an extreme value, and what kind of influence would it have? So median in the middle there would still be at 13.5, Q1 still at 8, Q3 still at 18. So my 5-number summary, my minimum would still be 3, Q1 would be the same, median the same, Q3 same, maximum though, that changes. So that would be how the 5-number summary changes. So if we throw in an outlier, it's either the minimum or the maximum that would change to that outlier value. Now if we calculate the range here, taking the maximum of 205 minus that minimum of 3, we'd have a range of 202 compared to our range of 17 previously. So this is an example of how it's influenced by outliers. This changes a lot. So because it changed a lot, we want to be careful of using that to describe our data, because really that's just one data point that's causing this extreme value. So we don't want to use it to describe the spread. But if we go and calculate our interquartile range, which would still be 18 minus 8, that's the same. So this interquartile range is resistant to outliers, which is fantastic. That's what we want with our skewed data, so that we're getting an accurate representation of center and spread. So when we have our skewed data, this is the route we're going to go. In terms of putting a sentence together with this, what we would say is the median is 13.5 to describe the center, with an interquartile range of 10. So that would be our sentence for center and spread when we have skewed data using our median and interquartile range.